Hello, how are you? Good. I'm also in a relatively shitty mood, so let's do some Rust. This will cheer us all up. So last time I stopped at this place in in my GOP implementation, and the issue I had specifically was I was not sure how to add a reference to a struct through a box. Just because, well, I'm not that familiar with Rust and the ownership and lifetimes and everything. But after looking at this guy's tutorial, Let's Get Rusty Smart Pointer like box thing in Rust, I gained some more insight, right? So this guy is actually awesome. I look up to him and I learn a lot from him. With this guy out of the way, so I actually was able to find the solution quite fast. There was a necessity to add a lifetime to my node's reference. And here somehow I completely lost it. And I want to experiment with it more in Rust's playground, just in order to understand how the hell do I build a simple tree of items where every child of a parent knows the parent. I think it's better to explain what I want to do with just file structure. So this is my start node, right? The folder, and the Rust folder knows that its parent is fun projects, and Rust is the parent to these folders, and every folder here knows the start node. The reason I want to build my structure this way is because, well, when I build the tree and this becomes my leaf, then I can trace back to where I came from and build a path to the source node and actually, build my action array with it. So with that out of the way, when we know that we want to build our path backwards in the end, let's maybe make my face bigger here and this bigger. And yeah, I decided to include the Let's Get Rusty um, thing, YouTube here. This is my initial JavaScript playing app that I tested with the initial algorithm. And this is the source for my Rust algorithm. It's not finished yet. I haven't pushed my last change yet. It compiled somehow, but I wasn't sure if I can use it still. So what I'm gonna do here is um, I already know that I need to have a node. It has some data that we are interested in. This is just a simple integer thing, right? I'm gonna sit here. And this is gonna be like a recursive struct, like b, like the next node or like previous node. Okay. So I'm gonna try and create a node. Let n, the start one, it's going to be node. data is going to be 1, B is going to be another node inside, which is kinda a parent thing that we want to have. Data of 0, like where we came from. All right, and the B inside it will be none. This will not compile for simple reason. Apparently, this thing is all right. So I don't have the semicolon. This is fine. All right. What else? What else? Node, 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 node. So I'm already doing something incorrect, and it's telling me, okay, you need to have a box. All right. So the first thing that the compiler is saying, okay, this is possibly some thing that is recursive, and it cannot figure out the size of a entire tree that you want to build. This is what the guy from Let's Get It Rusty says. So we need to have like a boxed finish size of it. Yeah. So I'm building up knowledge about it as I go. I haven't prepared this. I'm just playing with it. All right. So now, no. Struct node. I think I wrote it correctly. Okay, now here it says, yeah, it expected a box mismatched type. So immediately I'm getting like hints that needs to have a finite um, box thing, and this is going to be a none and still a box. So I want to build the intuition about it, because I don't really understand how the things that I built in my actual app worked. So none expected destruct, and yeah, and since this could be either null, meaning that there is no parent, like a first element, this should be a sum, or option, sorry, option. So this is the intuition I built already. If there is a possibility that there will be no value inside, that then it should be an option of none, like or some thing, and this immediately becomes some node closed parentheses, and this is none. It's already an option. Let's compile. It did. Let me write something. Print line. Yay, we here. Just to make sure that it didn't just hang somewhere. Okay. Print ln. How am I paid for being a developer? I don't know. Print ln. Yeah, my point exactly. So yeah, we are here. So this worked. Now the reason I'm building this test app is let's say this is our start node. We came from this node and we create some other node, it needs to say, okay, this is my start node in this same manner. And I don't want to store a node like directly inside the new one and it's a new structure. I want to have a reference to the node so that I don't copy over node every time I reference it in a way. Um, so yeah, let's actually remove that. Yeah, let's maybe create a let start node equals to this. Let's make it a bit prettier. And the data is 0 just to tell that this is a start thing, index, whatever. This is going to be the second one, and it reference to this is going to be its like came from reference, right? So this is a start node. It's boxed, none. Yeah, it's still compiled. And now I have this intuition that if I have another node, then let's call it 11. Will I be able to use the same direct like struct instance like object for the second one? No, because it was already moved. So we created the start node here. When we set it to first nodes, like set it as a parent, it's already borrowed by it, like moved. And from this point forward, we can literally assume that we don't have a start node anymore. And we cannot use it. And the structures that we wanted, like Rust folder, can say that fun projects its start node. Node.js thing cannot say that it came from here. So we need to have a reference, right? So this is a none, which is fine. This immediately needs to be also reference because we are referencing. And this is the problem I had literally in the code. When I came here in the iterator of available actions, I don't get struct immediately. I get a reference to it. The action is a reference. So it's wait, what am I talking about? The start node, sorry. I passed in the start node as a reference so that we don't copy way too many nodes and blah blah blah, referencing and borrowing. You kind of build up your idea of how it works, but my idea of how it works is I need to reference the thing I already know about. I know that in my upcoming recursive implementation, I will still pass my starting node, whatever it will be at this point, as a reference further, and it will not be like deleted by memory management because, well, it's still in the scope. So start node is still in the scope. And since I'm passing it as a reference, this should still work because these guys are referencing the things that still exists way over here. It's the value is not moved. We just borrow it. We kind of use it by trust that Rust gives us. gives us. All right, but it doesn't work because apparently see Rust says us that apparently it doesn't know the lifetime at which the thing exists in. It cannot tell, and it needs us to tell in which scope should it be visible. So just simply by following the instructions, apparently this is a lifetime that's kind of bugging me. I'm starting to understand it now with this specific example that I came up with. It says, okay, the node has to be of a lifetime, like slash whatever a will say that a is a lifetime. This means lifetime creation. So node will exist at this lifetime of this scope where it's visible. So everything that we pass in as its reference will have to be in the same lifetime. This is why it's saying apparently that in the box stuff on the line 3, it wants us to have a specific direction that whatever I pass in and store in a box is created at the same level, in the same scope as a start node, right? So start node is created in this scope, and this node is still created in this scope. So this particular variable is still here since we're not moving anything, right? So it knows that the reference is valid throughout the entire existence of these nodes until it reaches the end of the application where it can just kill everything, apparently. So this is a annotation on line 3. It could not compile because, oh yeah, I didn't specify as it suggested that the node itself, so both the smart pointers that we create with box new and both the smart pointers that we create with box new and the node itself, they should be created in the same lifetime so that there's trust between like compilers, static type checking. So this is actually mind blowing. We know that we came from this scope. I'm gonna call it scope. The lifetime is weird. The reference is built from the same scope, and the node itself that we pass in is created in the same scope. So if we build it, why is it not compiling? A reference to a box. Oh shoot, it should not be this because I'm already using the box, right? Maybe I shouldn't have done it. The box should be, yep, I was trying to be a smartass. Kill box, do this, and maybe same here. See, I was trying to reuse the same pointer, which is not possible, I guess. Maybe it was possible, but I'm not gonna test it. Yeah, technically it would be nice to have one smart pointer. Since I'm learning, yeah, this is fine that I'm getting errors. Oh yeah, it should be reference to a node on the line 15. What is it saying? Line 20. Start node. Some node. Oh my god, I'm failing so hard. So apparently maybe if I fail long enough, I will understand how it works by intuition, not from just copy pasting stuff over, so that the error count is less. Do this. So it compiled. So I needed to create an option right here. It's unique to this node here. And of course, this box needs to be some, and it's going to be a reference to the same node that I created before. So we reference this struct. We put it in the option thing, and it's a dynamic smart pointer. It's not a dynamic, sorry, this is a different thing. So I'm able to share the existence of one reference with multiple nodes. It's a tough one, but this is the way it should work. And naturally, whenever we use reference like this, I guess we cannot start node. We cannot go ahead and just change data to yeah, it's not allowed. Yeah, first of all, it's not mutable. Cannot assign even with this. Oh, it worked. Since I'm only referencing it and not deleting it, I still get to use the reference and change data inside. Wait, should I be able to print it? So I'm gonna output the integer value of start node. The data thing. Oh, nice. So as long as I use the same lifetime, I can trust my own code to modify stuff inside. And the modify stuff inside. This is mind-blowing. I didn't know that. But I built a tree of two items that reference one start node as a parent the same way as with these folders. Rust is pointing to fun projects, kinda. Node.js pointing to fun projects through the option smart pointer stuff. Yeah, are you saying I can even print the entire thing? I'm going to try and print out this. If I'm correct, as a B, it should have a normal 101 output with a reference of some things. Oh, it's gonna fail. And debug trait. Argument never used. Oh, because there's no formatting. There's an error. Cannot be formatted with the things that I said. Where's the stuff I can copy? Usually it gives me the display. Oh, yeah, pretty print. Yeah, derive, debug. So this is a language that is really awesome to write with this debugger, like a helper thing. If you look at the signs correctly, then you will probably be able to compile. So now it's giving me the error. That I cannot do anything with the data on the line 21. And then it's borrowing something. Oh, come on. And one, can I still print out data? So apparently it's not possible because it's trying to borrow stuff from the source. And oh, this is interesting. Well, technically it's not interesting, but maybe if I borrow it again. Not borrow. Is there a dereference thing? Oh, this is becoming silly. This is another level of understanding that I received just with this. Okay. Yeah, I'm not sure. Whatever. This is not the things that I wanted to exercise. So here I wanted to exercise if I can reference the same node sequentially, just because in my code I will have to. But my code is more complicated in the sense that there's like recursion going on and I'm passing references around. It's borrowing everything around. And since I'm not that good of a Rust developer yet, um, yeah, I needed to test it in a simpler manner where there's just a few elements. This worked for me somehow, but I wasn't sure if it's gonna work for me later. But since I'm able to pass references around, why the hell not? My node, the start node that I passed here, it's technically in the same lifetime. I passed the start node to the build graph. There's a reference still. There's nothing asynchronous going on. I'm not doing anything. I'm creating the node. Yeah, this is the reference. It's the same way that we have here. What? The same way as we have it here. With the only difference is that the start node is already a reference, and yeah, cool. So yeah, this is the way to do it. Well, in my code I will not have to modify stuff in the tree. This is not the point of my algorithm stuff, like the implementation. I'm building the tree one way, and then I should be able to go back up from the solution found by, like, when we get a leaf of the tree, and we only need to know the way up. It's not a double linked list, it's a singly linked list referencing backwards to the source. So I hope you learned something. And again, definitely check out Let's Get It Rusty. I really, really, really enjoyed watching the guy and all the freaking commercials you see. Yep, top tall. Maybe you work in there. Cheers. Bye.